and any one substance, how it is the color is produced. And the color is produced depends upon the wavelength. It means any one substance is and color is appearance. Substance is observe the wavelength in the visible region electromagnetic spectrums and reflect the wavelength, that one the color is appearance. It is simply say any one substance is the color, any one substance is the light radiation is observed, light radiation is observed and particular wavelength in the visible region of the electromagnetic spectrum and reflect the wavelength in the spectrum is called that in the color is appearance. It means this one is the substance. This is meant to be a substance. This one substance is observed the wavelength in the visible region of the electromagnetic spectrum. And when it is observed in the wavelength is the orange. Orange is observed and reflect the wavelength and reflect the wavelengths and the blue color. Complementary color is appearance is the blue color. Means observe the wavelength is not a color is observed, and observe the wavelength is not a color is appearance. When it is the reflect the color is appearance. It means any one substance is observed the wavelength in the particular wavelength in the visible region of the electromagnetic spectrum, that one, and reflect the wavelength. Reflect the wavelength is the appearance of the color. It is the, for example, any one substance is observed in the orange color and reflect the color, and complementary color is the blue color. Any one substance is observed that in the purple color and reflect and complementary color is appearance to the yellow, and then observe the substance is the red color, complementary color is appearance to the green color. It means any one substance is observed and any one color, that one in the complementary color is produced, that one is the appearance of the color of the substance. Therefore, then you already know about it, and how is the color is produced. Then is go to that in the go to the and you already know all the wavelength, all the combination of the wavelength in the spectrum and visible region of the spectrum, visible all the wavelength of the visible region of the spectrum, that one is counted that in the white color and color is appearance. Any one wavelength and absence of the wavelength in the visible region of the spectrum is called that in the dark color and black color. It means it is what is the indicate this one, and this one is indicate is come to that in the, and color is appearance depends upon in the wavelength. Color is appearance is depends upon in the wavelength, and observe the color and reflect in the another color is produced. Therefore, this one and combination of the all the wavelength, combination of the all the wavelengths, combination of the all the wavelength in the spectrum in the visible region. Sorry, combination of the all the wavelength in the visible region. In the visible region, combination of the all the wavelength in the visible region, that one is come, and the color is appearance is the white color is come. White color, example sunlight. And another one is the absence of wavelength. Absence of wavelength in the visible region. In the visible region is the darkness. Darkness means is the, and black. Darkness is come. Simply say everything the darkness. It is indicate is what? And observe that here combination of the all the wavelength in the visible region, and white color is come. Example is come to that in the sunlight. And another one is the absence of the wavelength. Absence of the wavelength in the visible region, and darkness is produced. It is indicate, and color depends upon of the wavelength. Observe the one color reflecting the another color. It is like to be a complementary color, and this one the color is indicate, color is depends upon in the wavelength. Simply, what is the observation of the wavelength, and observation of the wavelength is that one is color is not produced, reflecting the wavelength, that one is the color is appearance. This one is example, best example. When it is that in the and observe that in the orange color, and complementary color is come to that in the blue, and observe that in the purple color, and complementary color is the yellow, and observe that in the green color, complementary color is appearing the red. This one is already combination of all the wavelength. In the visible region, the white color. Example is sunlight. The color is very important, and wavelength. This is absence of the wavelength in the visible region. That is called that in the darkness is the black. Absence of the wavelength. No color is produced. It is like to be a colorless, and dark is appearance. It is indicate. What is to indicate this one? 2 points, and depends upon the wavelength. The color is depends upon the wavelength. That one is come to that. Observe the one wavelength and reflecting the wavelength, and it is the color is produced. Then after that, and transition metals. You already know transition metals. How transition metal is color is produced. Transition metals is color is how it is produced. Transition metals. How is the color is produced? And transition metals is already N-1 d. This is the N-1 d is called orbitals, and N-1 d orbital is the degenerate. What is the indicate is the degenerate? Degenerate means it is the identical energy. Identical energy or same energy. Identical energy is same or same energy. It means transition metals. How is color is produced? N-1 d orbital is degenerate. Degenerate is indicate is what? Identical energy or same energy. And this one, anyone same energy is come when it is the ligand or aqueous solution, other stimulus. When it is the and absorb or reflect, observe that what happened that, and energy is difference. That one is the color is produced. First is the N-1 d orbital is the degenerate. Degenerate is indicate is what? Identical energy or same energy. When it is the ligand is the and pushes and approaches to the N-1 d orbitals or aqueous solution approaches or observe that the energy is changes and color is appearance. How is color is appearance is observe that now, and this one. How is color is appearance? And this one N-1 d. For example, is taken out in the cobalt 3 plus or cobalt first is. You already know cobalt is what? 3d7 and 4s2 outer shell. The valence shell is come to that in the 3d7 4s2. When it's the cobalt 3 plus, how many electron losses? 3d6, 3 electron losses and 4x0. Then after that, this one you already know T2G, and then after that another one is the EG. T2G and EG. 1, 2, 3, 4, 5, 6. Anyone, you already know transition metals is you already know, and N-1 d and orbitals, N-d orbitals. Anyone ligand or solution is approaches to the N-1 d orbital, different energies formation, the color is produced. 1 point. And how is color is produced, and that one is the explained now. And electrons, anyone ligand or light radiations is absorbed, and the electrons is jump from the ground state to excited state. The light is absorbed. The electrons is jump from T2G to EG. Electrons jump from the ground state to excited state. The color is appearance. The electrons is jump here. Right. This one is the electrons is jump from the ground state to excited state. The color is appearance. Observe that again say CO and cobalt, you already know 3d7 and 4h2. How is the transition metal is color is appearance, and cobalt 3 plus 3d6 and 4s0, and this one is the 3d6, and this is the T2G, and this is the EG, and light is absorbed. the electrons is jump from the ground state to excited state. The ground state to excited state, and color is appearance. Color is appearance. The ground state to excited state is go to that in the color is come. And then another one example. For example, zinc 2 plus zinc. Zinc is what? And 3d10. Outer shell is the 3d10 and 4s2. And 2 electron loss are 3d2. 3d10 is come. 3d10 and this one is come. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what? T2G and this is the EG. And light is absorbed. Light is absorbed. Here observe that, and this is the you already know, and zinc. Zinc is what? 3d10 and 4s2. Zinc 2 plus 3d10 and 4s0. And 3d10 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The light radiation is come, light is absorbed, and no electrons is jumping. No available of the space. No available of the space, and no electrons is jumping from the ground state to excited state. No color is appearance. No color is appearance. No, this one is absorbed, and no electrons is jumping here. If you observe that no electrons is jumping, no color is produced. Therefore, it is indicate is what? This is the colorless. Why? Because it's the completely filled of the electrons, and no unpaired electrons, and no available of the space is the electrons is jumping from the ground state to excited state. No electrons is jumping because it's the no space is available. Therefore, it's the no color is appearance. Then another one example is going to that in another one example. Scandium. Scandium 3 plus. What is the scandium outer shell electronic configuration? 3d1 and 4s2. Scandium 3 plus 3d0 and 4s0. Here this is the T2G and EG. The light is absorbed. Light is absorbed. Light is absorbed. No color is and no electrons is ground state to excited because it's the no electrons here. No electrons here, and it is the no electrons is here. Observe that again. Scandium 3 plus. Scandium is the 3d1 4s2. Scandium 3 plus 3d0 4s0, and this is the T2G and EG. No electrons is there because it's why? This is the 0. No electrons is there in the orbitals. Light radiation is come. No electrons is jumping. Therefore, it's like to be colorless. This is like to be colorless. Why? Because it's the colorless. No electrons is jumping. No absence of the electrons. No light radiation is absorbed that in the electrons. Therefore, it is indicated is the colorless. Again, scandium 3 plus scandium 3d1 and 4s2. Scandium 3 electron losses 3d0 and 4s0, and here T2G and EG. No electrons is jumping from ground state to excited state. No electrons is jumping from the T2G to EG, and therefore is the no color is appearance. Therefore, this is the transition metals. If you have observed that in the 3 examples, and the CO3 plus 1 electrons is jumping, therefore is the color is appearance from the ground state to excited state. Another one is go to that is the zinc 2 plus, completely filled of electrons. No electrons is jumping because it's no space is available in the present in the orbitals, d orbitals. Therefore, it's no electrons jumping there, and no color is formation, no color is produced. And another one is go to that in the scandium 3 plus, and empty space, empty orbital is there, d0 orbital is there, and therefore no light radiation is absorbed that in the electrons, and from the ground state to excited state. No electrons is movement from the ground state to excited state. No electrons is go to that in the T2G to EG. Therefore, is come to that in the colorless. Conclusion, you already know. number of unpaired electrons is present in the n minus 1 d orbitals. And unpaired electrons is there, and electrons is jumping from the ground state to excited state, and electrons is jumping from the T2G to EZ. And absorb the unpaired electrons from the ground state to excited state, and that one is not a color is produced, and reflecting same energy and reflecting go back to the and electrons, that one is the color is produced. You already know when it is the blue color is absorbed and it is produced in the orange color, red color is absorbed and green color complementary color, the purple is absorbed and yellow color is produced. And you already know this is the last and concluding, and the light any one substance is color is produced is depends upon the wavelength. Observe the wavelength is not important, and reflecting the wavelength in the visible region of the spectrum, that is the wave, that is the very important first conclusion, that one. And the wavelength is very important and depends upon color. And observe, and then after that reflecting is come, that one is the color is appearance. Then if you go to that in the transition metals is the number of unpaired electrons is present in the n minus d orbitals, and n minus 1d is the difference energies produced, difference energies formation, that one also color is produced. This is the, and how is color is produced? Color is depends upon the wavelength, and transition metals is depends upon the number of unpaired electrons is present in the n minus 1d orbitals or subshells, and different energies formation, that is also color is produced. Electrons is jumping from and ground state to excited state, electrons is jumping from and T2G to EZ orbitals, that one is color is produced. And thank you for that watching for the video, and please subscribe to my channel, and anyone doubts, anyone queries, please comment the box, and I will answerable. Thank you very much.